In this video, we're going to walk through how we can determine the sample size needed for estimating a mu1 minus mu2 and p1 minus p2 confidence interval for a given margin of error. So we're going to do these both in the same video since the formulas are nearly identical. And for the first one, we're going to say n1 is equal to our n2 value. So we're going to say both of the sample sizes need to be the same, is equal to our z sub alpha over 2 for whatever our alpha happens to be. We're going to square that value and multiply it by our sigma 1 squared plus our sigma 2 squared. And all of that is going to be divided by our margin of error, or ME, and margin of error squared. So remember, the margin of error is just one side of that range. So depending on what that looks like for our confidence interval, so we have a confidence interval centered on our x bar value. For that difference, the margin of error is just that one side. So this would be considered your margin of error. Now to determine the same thing for our proportions, we have again almost the same identical formula. We have n1 equals n2, and we have that equal to our z sub alpha over 2, that value squared, times, now we have p1 times q1 plus p2 times q2, and all that over our margin of error squared, so ME squared. Now for this, we're most likely going to have to substitute in, so we're going to have to substitute in p1 hat times q1 hat, p2 hat times q2 hat. And we'll have to do probably the same substitution in for our sigmas, so we'll probably have to have our s1 squared plus s2 squared going into this part of our fraction up here. So again, we'll probably have to substitute that in, but this is basically how we can calculate the necessary sample size for a given margin of error once we have some idea of what the standard deviation is for those two different values.